Okay, page 10 is actually an error. I don't know how this page randomly got stuck in there. So we're going to change the problems on page 10. We still need it. So on page 10, on the top of it, I want you to put 1.2. We're still on 1.2. This is like part B. Difference of squares. So we're still factoring. We're going to do difference of squares. Okay? In order for us to factor what's called a difference of squares, we need three conditions. Okay? So the polynomial must be, first it must be a binomial. What does binomial mean? Does anyone know? Two terms. Okay? It's only two terms. That's a binomial. If you need to make yourself a note there, it's two terms. Second thing, it needs to be a subtraction problem because that's the word difference. So it must be a subtraction problem. And then the third thing is that both terms must be perfect squares. Both terms must be perfect squares. Does anyone know what a perfect square is? An example of one? 25, 64, 36. It's any number times, yeah, so like 6 times 6 makes 36. So 36 is considered the perfect square. 6 is called the square root. 8, who do you appreciate? Okay, over here on the side, I want you to make a little chart. Over here on the side, I want you to make a little chart. The X category, this is called the square root category. And the X squared, these guys are the perfect squares. So this is the square root column. This is the perfect square column. We're going to make a quick list. 1, 2, 3, all the way to 10. What is 1 squared? Okay. I was hoping more than one person would know that one, but I see we have some work to do. 1 squared is 1. 2 squared is, that means 2 times 2, right? 3 times 3, or 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared. 7 squared. 8 squared. 64. 9 squared. 81. And 10 squared. You need to know these by heart. We're going to use them enough that you're going to know them. So when I say, is this a perfect square? You are looking at this column right here. So when I'm asking, is such and such a perfect square? You want to look in the perfect square column. Okay? So we're going to, for lack of a better word, scribble out these problems, and we're going to write our own problems in. Okay? So number 4 is, we're going to, I mean, you don't have to really scribble. You can just cross it out. Okay? So number 4 is going to be a squared minus 4. That's going to be our problem. A squared minus 4. Now, if we look at our list of things, it must be a binomial. Is a squared minus 4 a binomial? Two terms, right? Is it a subtraction problem? Yes? And is a squared and 4, are they both perfect squares? Okay, so a squared, right, that's a times a. And 4 squared, or the square root of 4, I'm sorry, is 2 times 2. So both of them are perfect squares. So this is a difference of squares, and the way that we factor this is such. You're going to go ahead and set up your 2 parentheses. What did we say the square root of a squared is? Look over here. The square root of a squared would just be a, right? So we're going to put an a in each of them. And then what's the square root of 4? 2. 1 is plus, 1 is minus. It doesn't matter which one is which. You could also write it like this, a minus 2, a plus 2, and it's going to be the same thing. There should not be any space between your 2 parentheses. They should be right next to each other, touching each other. That's difference of squares.
The top one needs to have a square on each of them.
Oh, the square root, you don't have to do that. That's just kind of showing your work, okay? So this is going to be your final answer, a minus 2, a plus 2. Again, a plus 2, a minus 2 is the same thing. So when we're grading, you don't have to say, is it okay if I switch the signs around? You know that it's okay, all right? That one is your final answer. If you were to FOIL that or multiply that back together, you're going to get a squared minus 4, okay? All right, let's do another one. Number 5, let's cross that out. We're going to do n squared minus 64. Is it a binomial?
Yes.
Is it a subtraction problem?
Yes.
And are n squared and 64 both perfect squares? Yes, 64 is on our perfect square list. So the first thing I do is set up my 2 parentheses.
Put n in each one.
N comes first, so I'm going to put n in each one of them. And we know the square root of 64 is 8. Notice I'm not putting 64 in there, I'm putting 8. One's plus, one's minus. The reason it has to be plus and minus is such. Watch what happens. If I were to multiply this out, you don't have to do this on your paper, just watch up there. If I were to multiply this out, these have to be plus and minus to cancel each other out. One has to be plus, one has to be minus, so that I have n squared minus 64 left. You guys see that? That's why it has to be plus minus. Okay? All right, number 6. We're going to have x squared minus 81. X squared minus 81. Is it a binomial? Is it a subtraction problem? And are both of those perfect squares? Okay, go ahead and set up your parentheses.
Mm, 81.
What about 81?
Is that right? What you said, 81?
Yeah, 81. X squared minus 81. So we're going to put an x in each. What is the square root of 81?
9.
9. So they each get a 9. One's plus, one's minus. Any questions so far? You feeling okay on these? These are pretty easy. But it's algebra 2, so what are we going to do? Take it up a notch. Okay, number 7 is the next one. K squared plus 25. Oops. K squared plus 25. Is it a binomial? No. Is it 2 terms? It is 2 terms, right? Is it, are they perfect squares?
No.
Yes, K and 5 will make perfect squares. But is it a subtraction problem? No. That was your on Family Feud. You know how they did that? Okay, so can this be factored? Do they have anything in common?
No.
They don't have anything in common, and even though they're perfect squares, it's not a subtraction problem. Sometimes students think that this might be the answer. K plus 5 and K plus 5. Anybody thought maybe that might be it? This is what happens. If you were to multiply that out, you get K squared plus 5K plus 5K plus 25. K squared plus 10k plus 25 is not the same thing as what you started with. Okay? So we will not factor if it's a plus sign. This is wrong. So instead we said if something is not factorable, it's what? Prime. So we would write the word prime here. Now, later on in the term, we will learn about what happens and how we can arrive at k squared plus 25, and I'm sure you're dying to know what that is, but I'm going to keep that a secret. Keep you in suspense. I know.
Can't tell secrets, right?
That's right, so I guess you won't ever know. Okay, here we go. Number 8. 100 minus c squared. Is it a binomial? Yes. Is it subtraction?
Yes.
And are they perfect squares?
Yes.
Yes. So we can factor this. However, why does this look a little bit different?
Because the numbers first.
Because the constant is first. So if the constant is first, then when you take the square root of 100, the 10 has to go first. If you switch it around, it's not going to be the same answer. All right? So that whatever goes first stays first. So your 10 has to go first. Okay? And then they each get a C. One's plus, one's minus. Questions on that?
Why does the number of the position matter?
Okay, so if you did C minus 10, C plus 10, right, that's what you're thinking maybe it should have been. Watch what happens. If you're going to multiply these back together. These two cancel and you have C squared minus 100. Is that the same thing as 100 minus C squared? Do you see here the 100 is positive? Down here the 100 is negative? They're not the same thing, right? That's why order does matter. Okay, good question. Okay, number 9. 25x squared minus 49. 25x squared minus 49. Is it a binomial?
Yes.
Perfect square? Is 25 and 49 perfect squares?
Yes.
Is x squared a perfect square?
Yes.
So we just have a little bit extra on this one. Okay? So we're still going to set up our parentheses. We know the square root of 25 is 5. What's the square root of x squared? Just x. And it's going to smash together with the 5. Because the 25x squared is smashed together. So then you're going to put the 5x smashed together. What did you say, Brooklyn? Minus 7 plus 7. So same process, you just have a variable now. How you feeling?
Good.
Do this all day long.
No.
That's what you were wishing.
No.
Okay, go down to number 10. Number 10 is going to be 4h squared. 4h squared minus 64g squared. 4h squared minus 64g squared. 4h squared. Now, before you start going, what does it say there at the top?
Multiply step.
And then it says look for the what?
GCF.
Look for the GCF first. Is there a greatest common factor between 4 and 64? 4 can be reduced out of that. So we need to divide by 4 first. What happens when we divide by something? Does it just go away? Where does it go?
Before the parentheses.
Goes in the front of the problem. So let's rewrite this just as 4 times h squared minus 16, because 64 divided by 4 is 16, g squared. So we pulled the 4 out first. Do we still have a difference of squares?
No. Yeah.
H squared is still a perfect square. 16 is a perfect square. G squared is a perfect square. So can we do the difference of squares again?
Yeah.
We can. Okay? So we're going to forget about the 4 for just a minute. Put that off to the side for just a minute. And let's go ahead and factor h squared minus 16g squared. They're each going to get an h. The square root of 16 is 4.
And G.
And the g is going to go with the 4, right?
And let me guess, you're gonna add that 4, you're gonna bring it down and put it next to the big front.
Excellent. And this 4 is going to come down to the very front.
Who would have thought?
We're putting our first lesson skills together with this lesson. Okay, number 11. 16a squared minus 121b squared. Go ahead and do this one on your own. 16a squared minus 121b squared. If you don't know if 121 is a perfect square, you can do a square root on your calculator. What is the square root of 121? Don't shout it out. Try it on your calculator if you don't know. If you don't know how to get the square root button, let me know.
So,
Who wants to volunteer their answer? Someone who I haven't heard from today very much. Olivia, I haven't heard from you very much. Go ahead, girl. What do you have in the first term? What's the square root of 16?
4.
Okay. And the square root of a squared? Okay. One's plus, one's minus. Okay. Then what? Is 121 a perfect square?
Yeah.
What is it?
11.
Perfect. And each of them get a what? Good. 4a minus 11b and 4a plus 11b. Yeah? Give yourself a little high five, everyone. Okay. Okay, number 12. 4c squared minus 5d squared. 4c squared minus 5d squared.
so 4C
Okay, these are not perfect squares.
Are all of them not perfect squares, or is it just one thing that's not working?
Well, the variables are perfect squares.
And
but
4 is a perfect square. But what is not a perfect square, Crystal?
5.
5 is not a perfect square. So can we factor this? No? Cade, what do we write instead? Thank you, Cade. Prime.
A lot of cages in here.
I know. Some of them sound high-pitched, too. Okay. Just a few more, guys. You're doing great. 64 m to the 4th. Ooh.
Fancy.
64 m to the 4th minus 9n squared. Okay, 64 m to the 4th minus 9n squared. All right, let's talk about this. Is it a binomial? Okay. Is it subtraction? Okay, now before you jump to the gun, is 64 perfect square? Yes. We can agree everything up there is a perfect square, except what are we having some trouble with? M to the 4th. Okay? But let's think about this. Is 4 a perfect square? What? Who just said that?
Me.
What did you just say?
M squared, M squared.
Isn't m squared times m squared? Isn't that m to the 4th? So is m to the 4th a perfect square?
Yes.
Ooh, okay.
I was already going to start writing the m to the second power.
Oh, I thought you were going to say you're going to start writing prime, and I was going to tell you no, try again. Okay, so think about that. M to the 4th is m squared times m squared. Okay, go ahead and see if you can now factor this with knowing that. See what you can come up with. Mitchell, are you volunteering your answer?
Well, if you want.
Okay, sure.
I said 8m squared plus 3n,
Whoa, whoa, whoa. Plus 3n. Okay.
and then I did 8m squared minus 3n.
Does anyone agree with Mitchell? 8m squared plus 3n, 8m squared minus 3n? I would also agree. Nice work. So just because we see a higher exponent doesn't mean we panic. It means we do a little bit of extra work. Okay, number 14. The reason we do so many examples in class, guys, is because when I first started teaching math, what I heard from my students is, I wish my teacher had done more examples so that when I got to the homework, I knew what to do. Because I think doing like 2 examples is often not very helpful when you get to the homework, because as a math student, I remember thinking, we didn't even do anything close to this in notes today, and I have no idea how to do this problem. And because of what we're trying to do, a year of content in 30 days, I want to try to give you as many examples as I can so that you don't feel like, oh, I have no idea what to do. So don't grow weary in doing examples, okay, because it's a good practice for you. All right, 2 left, and then we'll be done. 3x to the 4th minus 48x squared. 3x to the 4th minus 48x squared. Okay. They're not perfect squares, but James, what are you thinking? Is it prime? What are we thinking?
I'm
Greatest
throwing-
common factor.
Yeah, I was about to say throwing the 3 out to the outside.
Okay, we can throw the 3 out. Is there anything else we could throw out? X what? X squared. That's the greatest common factor, right? Is 3x squared. And where do we throw it out to?
Outside the parentheses.
Out to the front. So that leaves me with x squared, right? Because the 3's cancel. And then 48 divided by 3 is what? 16. So I have minus 16. And the x squareds are gone there. Now are we finished?
Nope.
Ooh. Because we can do x squared minus 16, right? We can factor that. Okay, let's go ahead and factor x squared minus 16 then. Okay, so you had 3x squared on the outside, x plus 4, x minus 4. Any questions on that? Okay, try 15. Oh, wait, you have to know what it is. Just kidding.
Well, technically, I could do 15, but I wouldn't be giving you the answer you were expecting.
That's right. Okay, m cubed n minus mn. Okay, so if you look at it and immediately like this doesn't work, what should we try for next?
Common factor.
Okay, so see if there's a common factor.
And that would be m and n.
Okay, see what you can do. What is mn divided by mn? Be careful. Be careful when you divide out mn. Mn divided by mn is not 0, right? It's 1. You don't have an m minus n anymore. Divide by mn and divide by mn. See what happens. Yes.
How could you do that?
Okay. We need to be careful when we are dividing that we divide each term. Some of us are getting lost here. When we divide mn out, I still am left with m squared in the first term. Those n's cancel. And then mn divided by mn is 1. Is this all the way finished?
No.
Is 1 a perfect square? It is, right? 1 times 1 makes 1. Okay, so go one more time.
Minus 1.
Oh wait, that was cubed. I thought it was squared. That's why I was held up.
So I have m plus 1, m minus 1. See that? You got to be on the lookout for the ones.
What was messing me up is because I did mn and then it didn't register
did
that I
back-
still had m squared.
Oh, yep, you got to be careful
So
about
then
that.
I still,
Okay, any questions on this page?
No, now do your homework on the next page.
Your homework is to do page 11. Okay? Page 11 is your homework. And
Nope, no.
go back to page 9, please. On page 9, I need you to do the evens. So we did the odds as examples. I need you to do the evens. Okay, so page 9, the evens, 14, 16 through 24. Page 9, the even numbers, and then page 11. That's your homework that I'd like you to get started on, please. Now, I will tell you this. Factoring is the foundation of Algebra 2, which is why we will spend so much time. I mean, you will factor till your eyes are bleeding. It's what it will feel like, till your hand is going to fall off. But if you do not know how to factor, you will not be successful in Algebra 2. Okay? That's why we hit it hard and we hit it at the very beginning. Okay?